Good morning. This is Mr. Beckstrom. Today I want to take a look at an example from Section 4C. This is savings plans and investments. And the question is using the savings plan formula to answer the following question. Or use the savings plan formula to answer the following question. At age 35, you start saving for retirement. If your investment plan pays an APR of 4%, and you want to have 1.2 million when you retire in 30 years, how much should you deposit monthly? So first we have to know what the formula is, and that is right here. So let me make that a little bit larger. So it's kind of a complicated formula here, so we need to make sure that we take our time and really kind of identify these variables. So the payment is what we're solving for. That's our monthly payment. So our A is the accumulated amount. So that would be the total amount including interest and principal. So that's the amount that we want in 30 years. So that would be 1.2 million. So I'm just going to write that down. So A is equal to 1.2 million. I'm going to write that out. 1.2 million. All right, the next thing we want to do is we want to do the APR over the N. So let's do those first separately. So APR, that's the annual percentage rate, and we want to put that in decimal form. So that's equal to 0.04. Our N is the number of times per year. So here we're talking about monthly, so that's going to be 12. So our APR over N, which we can just write that since we see it in two different spots, is going to be 0.04 over 12. Now, if this is a nice constant, that means if it ends in a non-repeating fashion, then we could just write that out. If it's something that's repeating, then I can just either leave it in fraction form, or I can make sure that I keep at least like eight decimal places. So make sure that you don't round this too short if it's a repeating decimal. But I have a feeling this will not be a repeating decimal. So let me pull my calculator out here. And lost that. And we're going to do 0.04 divided by 12, divided by 12. And, oh, I'm sorry, this is a repeating decimal here. So this one, I'm actually just going to leave this for this one just as 0.04 divided by 12. So when I put this in the formula, I'm just going to leave that in parentheses. So I'm just going to leave that as 0.04 divided by 12. All right. And then we need to know the N times Y. So we know the N. The Y is the number of years. That's equal to 30. So the N times Y, the N times the Y is going to be 12 times 30. So that will be equal to 12 times 30, 360. All right. So let's go ahead and start putting this in here. All right. So I'm doing this in a graphing calculator. If you're doing it in a scientific calculator, you might want to do this a little bit differently. You might end up having to estimate here or use like 8 of these decimal places. If you do, then just make sure you're using enough of those. But here I can kind of put all of this in. So I'm going to start with the top. So this is going to be the APR over N. So that's the 0.04 divided by 12. Close parentheses. And this is going to be divided by And this whole thing is going to be in parentheses. So open parentheses again. Oops, that should be open parentheses. 1 plus. Now remember, this APR over N needs to be in its own parentheses. So I'm going to put that 0.04 over 12, 0.04 over 12. Again, I could have put that as in a decimal approximation as the 0.00333 with a bunch of threes, but I would have need to have put a bunch of them. And then, so that's just the APR over N, so I need to put this closed parentheses there. Raised to the 360, so raised to the 360, push it over here, -1, -1, and then we need that last closed parentheses. Enter. We get this value here, and then we need to multiply that by our accumulated value, so times 1.2 million, so that's 1, 2, 0, 0, and then 3 more zeros, and we get 1728.98. So our answer is 1728.98. Let me just check this one. And that's it. And if you have any questions, just let me know. But again, a couple of the tricky things here is we had a repeating decimal here, so we need to make sure that we either just plug in the actual fraction or we use a lot of decimal places in order to make sure it's really accurate. If we were to just plug in, for example, 0.003 for that, there's a good chance that we would have actually gotten this wrong because that's just not accurate enough to get the final answer correct. The order of operations is really important. Just make sure that you have all of your parentheses. If you're missing some parentheses, it's going to do those operations in the incorrect order and give you something that's way off. And just make sure that you also have your variables correct. The n here, that kind of tricks people up a lot of times. Just make sure you understand what that is. That is the number of periods per year. So we have to look at how many times we're, in this case, depositing per year. So it's monthly, so that would be 12 times per year. If you were depositing it daily, that n would be a 365. If you were depositing it weekly, that n would be a 52, and so on and so forth. All right. I hope you all have a great rest of your week. Thanks.